In June 1971, at just 12 years old, I first laid eyes on the Spinks Akromaster and dreamed of creating it as a radio-controlled model. Fast forward 53 years, and after retiring, I decided to design a model of this beautiful aircraft using Fusion 360 software. After 6 months of dedicated work, I'm excited to share the completed design with you. I hope it serves as a valuable resource for anyone interested in building this model. The model features a wingspan of 2.58 meters and is powered by a 60 cubic centimeter 4-stroke gasoline engine. The design process began with creating a reference model using surface modeling techniques. This reference model was then divided into sections to develop a paint design, with each section assigned a distinct color. I have included all the sketches in the design for those who may find them useful. Both the reference and paint designs were created with design history captured, but this history was removed when the construction design began. Since the reference and paint designs overlap, I recommend displaying only one at a time for clarity. The paint design incorporates various decals to enhance the model's appearance, including a sticker commemorating the 6th World Aerobatic Championship held in Hullivington in 1970. The construction design is offset from both construction and painting designs by approximately 0.5 millimeters, creating an impression of painting. The construction design drawing is organized in a browser tree format, utilizing a hierarchical structure that includes sub-assemblies for key components such as the fuselage, wings, and stabilizers. Each subassembly can be further divided into logical subunits, like the fuselage bottom or left aileron. This breakdown continues to lower levels, encompassing elements such as servo arms, screws, and nuts. The design incorporates all moving parts, just like in a real model. Let's take a closer look at the construction design by hiding the painting design. The construction is based on traditional plywood parts assembled together. The rear section of the fuselage features a structure made from 6 by 6 mm spruce spars. The assembly begins with the bottom of the fuselage, which is built on a flat surface with the top facing down. Next, a motor box is constructed and glued inside the bottom of the fuselage. After that, the top formers are added and reinforced with balsa supports. The build continues with the assembly of the vertical stabilizer and horizontal stabilizer supports. The fuselage is then strengthened by adding balsa sheeting to the rear and central sections. A canopy is built separately and hinged to the fuselage using 2 hinges. The motor is mounted to the motorbox firewall with 4 threaded rods and spacers, providing a secure fit. Choke and throttle servos are installed in the motorbox, and there is sufficient space beneath the motor for a muffler or silencer. Although the drawing does not include silencer fixtures, as these will depend on the specific type used. The cowl is designed to be made from fiberglass, utilizing either positive or negative molds. The landing gear legs are secured to the fuselage with 2 screws each, allowing for easy removal if needed. The rear wheel is attached to the fuselage with 2 screws and connected to the rudder arm by 2 springs. The horizontal stabilizer and elevator feature a straightforward construction using a plywood base and half ribs, reinforced with balsa sheeting. All hinges are inserted into holes that are drilled only after assembly is complete. One side of each hinge is shortened for easier installation. The wings are constructed using ribs cut from plywood, which are inserted into the main wing spar web. The main spar is formed by top and bottom spruce spars glued to both the ribs and the web, on a plywood base with ribs inserted into them, and both the wings and ailerons are covered with balsa sheeting. The wings are slid onto duralumin, joining tubes that are inserted into fiberglass sleeves. Both wings are secured in place with two M5 screws, along with washers and nuts. The wings can be removed by unscrewing the two main screws from inside the fuselage through the open canopy. All parts made from 3 mm thick poplar plywood have been arranged on a plane with dimensions limited to 1300 by 2000 mm, representing the CNC machine table. These components are copies of those from the construction design. Any shape changes made in the construction design will be reflected in this arrangement, and vice versa. If you decide to move or rotate the parts in this arrangement, ensure that you move or rotate them as components rather than as bodies. Otherwise, it will also affect the bodies in the construction design, leading to confusion in the overall design. I have created machine paths for all parts in the arrangement, stored within two identical milling operations. This approach was necessary because including too many chains in a single milling operation can slow down Fusion 360, making it difficult to work efficiently. For me, the critical number of chains was around 300, though this may vary depending on the computer being used. The simulation demonstrates that the milling process supports nested parts. It begins with the internal contours, followed by the external contours. This is achieved by selecting the Preserve Order option in the Passes tab of the 2D contour milling operation and carefully choosing the chains in the correct sequence, which can be quite time-consuming. The tool used for milling is a one-flute, 1.6 mm flat-end mill, operating at 12,000 RPM and moving at a speed of 300 mm per minute. As a result, the total cutting time exceeds 7 hours. Some parts are very small and thin, making a laser cutter a potentially better option than a milling machine. It may also be beneficial to use bridges to keep the parts in place. Otherwise, it could be challenging to identify some of them after milling. Additionally, I generated an NC program that contains about 45,000 lines of G-code for use with a popular Mach 3 machine. This concludes the basic description of the design I created. You can find the design at the link provided in the video description. I sincerely hope this video serves as a source of inspiration for someone. Thank you for taking the time to watch. I appreciate the opportunity to share this with you and hope you found the content both enjoyable and insightful. If you have any questions, comments, or feedback, please feel free to share. I truly value your thoughts. Once again, thank you for your time and interest.